Willie. 19. M divided by 2.1 is going to equal 5.1. The opposite of dividing by 2.1 is going to be what? Multiply by 2.1. 1 times 1, 5, drop the 0, 2 and 10, 1, 7, and how many decimals? Therefore, 10.71. Okay, what did you have? It just looks like you added it. Right? 1 and 1 is 2, 5 and 2 is 7. Maddie. We start with this one, then we multiply to that. That gives us the 1. And then we multiply the 5. Then as I move over to the number in the tens place, I need to move over 1 there, so I use that 0 as a placeholder. So I go 2 times 1, and 5 times is 10. You guys had that lattice stuff, is that right?
Oh, okay.
Josiah?
Number 17.
17. 4.3 plus J equals 6.1. It's a positive 4.3. How do I get rid of that? Subtract it. 11 minus 3, 8. 5 minus 4, 1. Line up decimals.
I think I just added it.
Now the bottom part, 21 and 22. Turn to page 74 in your book right now. Everyone, page 74. '74. Okay, so those are the examples for the addition. Those are 2 options that you can use based on page 74 in your book. Okay? And you can use that. Now, number 23. Write an algebraic expression for the phrase 7 less than a number. Now we go opposite. Now, they give us the word phrase. We need to come up with the algebraic expression. Yes? No. Willie? Good. Again, reference page 74. 74 for the subtraction. What do they give you as the example? They say p minus 6. So how do they use that? It says, well, did they even give us the less than? No, they don't even give us the less than one. That's right. Anyway, 7 less than a number. If I had it this way, it would be a number less than 7. Okay? Yes? 7 less than a number. No, in the book it doesn't say it. 24. 7 to the 5th power, any question there? They didn't even ask you to solve it. They just wanted you to write it with the base and the exponent. 25. If you just have 33 down for number, yeah, you got it. If you just have 33 down, it's going to be wrong tomorrow. If you just put 33 down, it's going to be wrong. Specifically, they want the distributive property. So, if we look and say 3 times a 5, whoops, plus a 6, they want us to use the distributive property, which means you have to show some evidence of the distributive property. So what we're going to do is we're going to take the number on the outside, 3 times 5. Since we're adding, we're going to take the number on the outside times 6. This here is evidence that you used the distributive property. 3 times 5 would be 15, plus 18 would be 33. I don't even agree with how they set it up, because what is essentially on the inside, what number is that when you put the 5 and 6 together? 5 and 6 together is what? 5 plus 6? It's 11. If we were doing it our way, and you had 3 times 11, how would you logically split up the 11? You wouldn't use 5 and 6. Logically, you would say 10 plus 1. I don't care, and I won't be able to know. I won't be able to know if you got your 33 because you actually added the 15 with the 18, but you better be able to show it. So whether it was easy for you to just take 3 times 11 and get 33, you still need to show evidence of the distributive property. Okay, are we clear? Anything on 26 through 29? Order of operations. Yes. Yes. 30 through 33. 30 through 33.
We have our test tomorrow.
34. Yes? Annie agreed to wash the car each week if she could get paid a penny the first week, or 1 cent the first week, 2 cents the second, 4 cents the third, 8 cents the fourth, and so on for 15 weeks. How much money will she be paid on the 15th week? So you will have to, well, not necessarily, but not a bad idea. If it were me, you could split it up. First week, second, third, fourth, fifth, sixth, 7th, 8th, 9th, 10th, 11th. And then we got to get 12th through 15th. So what's happening each week? It's doubling, right? So in week 1, 1 cent. Whoops. Week 2, 2. 4. 8 cents, right? How much here? 16. $1.32. Right? 264. $28. What do you do if you're not sure? 8, 12, 528. Week 11, 1056. Okay. 56 and 56 would be $1.12, so 21.12. 42.24, 84, and then 168 with 96. 163. Where did I mess up?
I knew it.
It was 128.
8 was 128? Well, that messes everything up. That's right, 256, 512, 1024, 2048, 4096, 81, what, 92?
Dude, keep doing it.
163.84, right? That better?
Yeah.
Good. So prime example that if you make one mistake anywhere, it messes the whole thing up. Okay? So how about 35? You'll see one like this tomorrow. They'll give you two order of operation problems, and they'll ask you to explain why they're not equal. The best evidence that you have is to just do the work. Here, you do parentheses first. 5 times 4 is 20. Here, you multiply first, get 12, add 2, 14.
Because it's not.
Not equal. That means not equal. Okay? So if you had tomorrow, if you just put 20 not equal to 14, that'd be fine. That'd be a good enough explanation for me. That would show me that you knew why. That would show that you knew the order. That would be okay. Really. You don't need to do that. Just solve them and just do that. So maybe you want to put that down on number 35 so that when you get to it tomorrow, you don't give me 3 sentences. This. That's enough of an explanation as I'll need.
Wait, what's that? Not equal.
Means not equal. Any other questions besides is the test tomorrow?
Wait, I have a question on that. The recording in like the video thing.
Anything about the test itself?